Hi everyone, my name is Eric Song from Carnegie Mellon University, and I'm here to present my paper using peer code review as an educational tool. So first, I will talk about our motivation. So our goal is to provide contextualized feedback at scale, but just providing feedback is not good enough. We also need to make sure feedback provided are beneficial to students. So good feedback needs to be accurate as it a part of the grade. It also needs to be high quality, so students know where and how to improve. Lastly, it needs to be timely, so students can incorporate it in the next project. Currently, the most common approach we see is employing many teaching assistants, but this is expensive, not scalable, and often not timely. So how can we solve this problem? Well, since our course is an online project-based course, we knew that whatever solution we implement, it has to be online as well. And since instructor reviews do not scale, we thought if we can somehow leverage the power of peers, then we can solve this issue. Therefore, we developed an online peer code review tool called PCR, where students are trained and then they will review their peers using a rubric. In our setting, each student will put in about 10% more work to review other assignments, and in turn, they will receive fast and quality feedback. For the instructors, this only requires constant amount of workload in spite of the class size. So after developing the tool, one important challenge that we face is how to train students to become better reviewers. You see, the problem is that students are just learning the material. How can we train students who just learn the material to effectively evaluate other students? Well, we need to support them and train them. First, we develop these descriptive and fine-grained rubrics for each project to guide students to provide high-quality reviews. Additionally, we implement a training phase to help them to understand how to apply these rubrics. And with these measures, a master the student becomes, well, not really masters, but they're certainly ready to perform peer reviews. In the next few slides, I will talk about key components of a good rubric and how the training phase can help students. Here is a sample rubric. As I mentioned in the previous slide, a well-crafted rubric can really help students in their reviews, but what makes a rubric good? Based on our experience, we discovered 3 important traits of a good rubric. First, a good rubric needs to have a descriptive, clear, and concise instruction to provide students with strong guidance. In this rubric item, we tell students what to look for and how they should assess the code segment. Additionally, a good rubric should also have fine-grained choices. If you take a look at the example on the right, instead of having a binary choice of good comments +5 and bad comments -5, we provide a more fine-grained set of choices such as no documentation, unsatisfactory, emerging, and satisfactory. This level of granularity helps reduce variances among reviewers, and associated with each choice is an explanation of what this choice means to help students understand what to and when to pick this choice. And lastly, the numerical points associated with each choice should be masked for students. When beta testing our tool with the TAs, we displayed the point values, but we soon realized that people were hesitant to give out harsh penalties. Therefore, we masked the point values of each choice to encourage a more objective review. If you're interested in more quantitative analysis, please take a look at our paper as we present more detailed analysis there. So in addition to developing fine-grained rubric, we also design and implement a training phase that helps students to understand the rubric, and they need to go through this before moving on to actual grading. The purpose of the training phase is to help them familiarize with the evaluation criteria using the rubric and train them to assess the code segment being evaluated. To set up the training phase, instructor pick what student to have the TAs review, followed by a verification step. The students are then trained by the TA model and cannot move to the actual reviews until they have passed. Well, now some of you may be wondering, is this lengthy process really necessary? Does it really help the student? To measure the effectiveness of the training phase, we ran an experiment where half the students receive training and half do not across 2 projects. As we see in the bar charts here, students with training not only have more accurate reviews, but they also have smaller variances among them. This shows our training phase really helps students with reviews. Now that students are properly trained, we should assess the quality of peer reviews. In the next section, I will present some of our findings on the accuracy of peer review based on the data collected over 2 semesters during which 226 students performed over 1,000 code reviews. First, we need to establish a benchmark, understand the intrinsic difficulty of grading. Here's a bar chart of the average percentage difference between the median TA review and other TA reviews across different projects over 2 semesters. We can see that accurately grading project-based assignments is difficult even for TAs. Sometimes there's significant disagreement among them, such as the case in project P1.2 and P4.1. One thing I want to add is that the TA receive in-person training. There's also a group discussion on the rubric every time before grading during our weekly staff meeting, and some gradings are even reviewed by the instructors. Yet, we're still seeing these differences. So this really highlights that accurate grading is far from a simple task. Now, let's take a look at how the students are doing. Here's a bar chart of the average percentage difference between median student review and median TA review across different projects over 2 semesters. And the red lines are the percentage difference among TAs that we saw in the previous slide. So in general, the difference between student and TAs review are slightly larger than those we see in the previous slide among TAs. But interestingly, both student and TA struggle with the same project, being P1.2 and P4.1. Our hypothesis is that in the first project, both student and TAs are new to the code review, and in P4.1, the rubric is very long, and also the question revolves around design choices and degrees of optimization, which lend themselves to different interpretations. But going back to the important question, the difference between TA reviews and peer reviews are still large. Is there anything we can do to remedy this? Well, one trend we notice is that median peer review of submissions with a lot of reviews tend to be close to the median TA review. To visualize this, we plot the average percent difference between median student review and median TA review versus the number of student reviews. As we see in the chart, the difference between staff and peer reviews become quite small with sufficient peer reviews. We expect that with 5 peer reviews, the median grade produced is more accurate than having a single TA review, which is typically the case in large project-based courses. So far, I've only talked about the PCR tool from the instructor perspective. We should hear from the student and see what they have to say about the tool. In the next section, I will share some of the survey results we have collected over 2 semesters. First, we asked about the workload. One of our major goals is not to impose too much extra workload. On average, students spend a little over 1 hour each week on code review, and more than half the students responded positively on the amount of workload. In addition, we see that less students complain about the workload in fall 19 semester, as the percentage of students who selected too much has dropped. Well, next, we asked them about the overall experience with PCR, and we have categorized the text responses into positive, neutral, and negative responses to produce this pie chart here. As we see in these pie charts, almost 2/3 of the students had a positive experience with PCR. However, there is a higher percentage of negative responses in the fall 19 semester, but upon closer inspection, we realized that most of the comments are regards to the workload. But we did see a lower percentage of students complaining about the workload in the previous slide. So I guess that is the nature of surveys, and we should take these numbers with a grain of salt. But the important message here is that most students are having a positive experience, and more than 2/3 of students are having either neutral or positive experience. And here are some of student words. One camp of students responded that PCR has helped them with coding style. One student in particular said, "It helped me understand how important readability and structure of the code is." Another camp of students said PCR provided them with new learning opportunities and different perspectives. One student said that PCR definitely helped me think about using the right data structure and semantics in future assignments. In conclusion, PCR is a scalable solution to provide quality and timely feedback. The accuracy of peer reviews is compelling and comparable to TA reviews. And almost 2/3 of students are happy about the workload and overall experience. The next important takeaway is that good rubrics are absolutely critical to accurate peer reviews. Good rubrics should be concrete with examples. It should also have fine-grained choices without displaying a numerical point. And lastly, the training phase is also necessary to familiarize students with rubric. And with that, that's the end of my presentation. I'll open up to questions.